Hi, this is Miss Hearn. Let's get started. In this video, we're going to determine the limits of a function as x approaches -2 by looking at the graph. So we're going to look at the limit from the left to the right, the overall limit, and then we're also going to compare that to the function value, or the y value, when x is -2. So let's start with part A, the limit as x approaches -2 from the left. Alright, so on my graph here, here's the x value -2. And so if we're asked for the limit as x approaches -2 coming in from the left, you just imagine running your finger along the graph and look at what y value you're headed toward. So as we get very close to the x value -2, we see there's an open dot here and then a filled in dot up above. We don't really care about that filled in dot. We just want to know if this curve were to continue in the direction it was headed, what is it headed toward? And so it's headed toward the y value of the open dot. So that's -1. So we would say that the limit as x approaches -2 from the left would be equal to -1. Okay, let's look at coming in from the right now. Coming in from the right means to the right of -2, following along the graph nearby. You're going to stick to the neighborhood around the value -2. So we're not going to be jumping over to these other pieces on this piecewise defined function. We're going to stay right close nearby. And coming in from right close by toward the x value -2, we also are headed, even if we're coming in from the right, we're still headed towards that open dot with a -1 y value. So that limit as x approaches -2 from the right is also -1. Now remember, the limit as x approaches -2 of f of x, it only exists if the limit from the left equals the limit from the right, which it does in this case. So the overall limit is also -1. Now let's compare that to the function value f of -2. Remember, in function notation, this is your x, and when we evaluate f, that's finding your y. So they're really just asking us to look at this graph and look at when x is -2, what's the corresponding y value. Here's our x value -2, and whoop, this is where the function has a y value, up here at the value 3. So f of -2 is 3 because the function goes through the point -2, 3. So to answer this question, we would say 3. Okay, now there's another question. This question says, is it possible to define f of -2 so that the limit as x approaches -2 of f of x is equal to f of -2? Okay, so what they're asking us is, could we adjust one single point on the curve and make it so that the function actually ends up at the point it was headed toward? The answer to that is yes, because we could take this single point here and just move it down and fill in that open dot. If we could just redefine the function at one single point, then the result would be that the limit as x approaches -2 from the left and the right would still be -1. But the function value would also be -1. f of -2 would also be -1. So the limit would equal the function then. By the way, this is what's called a removable discontinuity. So looking through our answers, I can disregard no, it's not possible. I can disregard it's not necessary to define f of -2 because they're already equal. That's not true. Yes, it is possible to define f of -2 so that the limit as x approaches -2 of f of x equals f of -2. What you would have to do is to define f of -2 to be -1, and then they would all be equal. So the answer is C. I hope you found this video helpful. If you did, please remember to give it a thumbs up, give it a like so other students can find the video.